Okay, so we're going to continue our work with solving quadratic equations. In the last lesson, we started learning about the second method of solving, which is solving by factoring. You'll notice that the learning target for this lesson is the exact same. We're still going to be solving by factoring. It's just going to be a different method of factoring. So to kind of review what we've been doing so far, I'd like you to take a look at this do now problem. And it says, what are two different ways that you could solve this equation? So I want you to pause this video, try to go on some loose leaf paper and solve this equation at least one way to get the values for x, and see if you can then figure out another way you could have solved the equation. Okay, so looking at two different ways to solve this equation, I see that the equation is 5x squared minus 20. So looking at this equation, the first method that comes to mind is thinking about the first method of solving that we learned, which is using inverse operations and square roots. So I would start by first adding 20 to both sides, which would give us 5x squared equals 20. Then I would go ahead and divide both sides by 5 and be left with x squared equals 4. Then we take the square root and we would be left with both positive and negative 2, so we could write plus or minus 2. So again, that first method of solving is just by using inverse operations and square roots. So thinking about another way that we could have solved this problem, I think about factoring, which is what we've kind of been working on in these last couple of lessons. So if I look at the left side of my equation here, 5x squared minus 20, I think about how I could factor that, and I notice that these both share a GCF of 5. So let's go ahead and factor out a 5 from the left side of this equation. We would then be left with 5 parentheses, x squared minus 4 equals 0. So I'm going to keep that 5 out front and see if I can now factor this part on the inside even further. Now I notice that x squared minus 4 is a problem that I could use dots factoring on because it's a difference of two perfect squares. I can break the x squared into x and x. I can break the 4 into 2 and 2. And then I set up my parentheses as x plus 2 and x minus 2. I'm going to bring down my 5, bring down my equal sign, and bring down my 0. Now, using the zero product property that we learned about in our last lesson, I'm going to set each piece of this equal to 0. So you'll notice I have 3 pieces now to set equal to 0. I'm going to set 5 equal to 0. I'm going to set x plus 2 equal to 0. And I'm going to set x minus 2 also equal to 0. So looking at the first equation, 5 equals 0, that doesn't make any sense. We can go ahead and eliminate that because 5 does not equal 0. X plus 2 equals 0 can be solved by subtracting 2 from both sides, and we'll be left with negative 2, because 0 minus 2 is negative 2. And over here, we're going to go ahead and add 2 to both sides, so we're left with x equals positive 2. So you'll notice that we get the same answers that we got in the first method of solving. Either way, we can get positive or negative 2. So what we're trying to show to you here is that there are so many different ways that you can solve these quadratic equations. We're just learning different methods that we could use to solve. So moving into this lesson here, you should still be looking at your packet, Solving Quadratic Equations Part 2. We're going to pick it up on page 4. So again, we're still factoring in this lesson here, but now we're going to be factoring when the a values are not 1, meaning we have some other number out front. So I want you right now to pause this video. Please read through example 1 and try to answer your 2 think right pair share questions. Okay, so looking at question number 1, it said, what must be done first before you can factor the quadratic equation? If you notice, this is what they were doing in step 1, which is to get the equation equal to 0. So remember, we called this standard form. So I'm going to say put equation in standard form. Which, as a reminder from our last lesson, is ax squared plus bx plus c equals 0. So just like with our last lesson, we still want to move everything to one side of the equation and have it set equal to 0. So now you'll notice that they ended up with this equation here, 3x squared minus 5x minus 2 equals 0. So because we have this 3 out front, we can't use the same method of factoring we did in the last lesson. We have to instead multiply our a and our c and then go from there. So what type of factoring were we using in this problem? Let's list this out for number 2. We called this method of factoring trinomial when a is not 1. So we're going to go ahead and list out these steps just in case this is something that you forgot. So the first step should always be to look for a GCF. That was the first thing that we always learned how to do, which if you notice amongst a 3x squared, a negative 5x, and a negative 2, there is no GCF. The second step that we learned is to multiply a times c. So that's our first and our last term. Then we're going to find factors of that product. So find the factors of AC that add to b. So in this problem, we were looking for factors of negative 6 that added to negative 5. So if we list the factors of 6, we have 1 and 6 and 2 and 3. And you'll notice that the two numbers they came up with were negative 6 and positive 1, because if I multiply those, I get negative 6, and if I add them, I get negative 5. So remember this important step right here. What they did is they took the middle term and they split it into those two factors. So for step 3, we're going to be splitting the middle term. Okay, so once they did that, they ended up with 4 terms, which then we know that after we have 4 terms, we can use one of the first types of factoring that we learned about, which is to factor by grouping. I apologize for the handwriting. So here we're going to be factoring by grouping. So you'll notice that they took out a 3x from the first 2 terms. They took out a positive 1 from the second 2 terms. Again, you'll know that you're factoring correctly when these two binomials match each other. And then they took that out front and brought the remaining factors down. Now again, in the last part of the unit, we would have been done at this point. But now we're going to use our zero product property and set the first binomial equal to 0 and set the second binomial equal to 0. Using our inverse operations, you'll notice that they got 2 values of x. So we're going to go ahead and try the guided practice problem. That's toward the bottom of page 4. If I were you, I would go ahead and pause this video, see if you can try to answer this by yourself. Okay, so looking at our guided practice problem here, let's just scroll this up, give ourselves some room. So again, I noticed from my notes that the first step was to get this in standard form. And right now this is not in standard form. I'm going to go ahead and move that 8x over to the left side by subtracting 8x. And I'm going to go ahead and also move the 9 because that also needs to come to the left side. So on the left side over here, I'll bring down the 8x squared. I'll bring down the negative 8x because there's nothing else to combine those with, but I can go ahead and combine the 3 minus 9, which would give me negative 6 equals 0. So notice that I've done step 1, which is to put this in standard form. So now I'm going to think about our method of factoring, trinomial when a is not 1. Let's look back at our steps. So the first step we said in number 2 here, it said is to look for a GCF. If you take out that GCF, it will make your life a whole lot easier, which in this particular problem, we actually have a GCF because I can divide all of these terms here by 2. And watch what happens. It will make this problem a little bit easier. When I factor out a 2, I'm left with 4x squared minus 4x minus 3, and I'll bring down my equal sign and my 0. So now I'm going to kind of leave that 2 out front and ignore that for right now. The next step in our method of factoring, if we look back at our notes here, says to multiply a and c, then find factors that also add to b. So if we notice here, our new a is 4 and our new c is negative 3. If we multiply 4 times negative 3, we get negative 12. So right now we're trying to come up with two numbers that when I multiply them, I get negative 12. And when I add them, I get our b term, which is negative 4. So if we think about the factors of 12, we have 1 and 12, 2 and 6, and 3 and 4. So thinking about from this list, how can we add to negative 4? I'm going to focus my attention on 2 and 6. And I notice that to make this true, I'm going to choose negative 6 and positive 2. Because negative 6 times 2 is negative 12. And negative 6 plus 2 is negative 4. So remember, once we have those two integers, if we come back to our notes here, we're up to step 3, which does to split the middle term. So I'm going to come back to my original work here, and I'm going to split that middle term up into negative 6x and positive 2x. Again, it doesn't matter what order you put there. If you want to put the 2x first and the negative 6 second, that's fine. Let's go ahead and bring everything else down. Okay, so notice at this point we're up to our last step, which is to factor by grouping. So we want to think about what's the GCF of these first two terms, and that would be 2x. So we're going to go ahead and factor out a 2x. We would be left with 2x. Let's try to neaten that up a little bit. We would be left with 2x minus 3. And if we think about our second two terms, 2x and a negative 3, they don't really have anything in common. So let's just go ahead and say that their GCF is positive 1. Which is a good thing, because if you notice at this point, we're left with 2x minus 3 and 2x minus 3. That all matches up. Just to keep our work organized, let's bring down the 0 and let's bring down the 2 that we took out front. Notice that I switched to those square brackets. They're the same thing, it's just a different way of writing it. So I notice that both of these share this 2x minus 3. So I'm going to go ahead and factor that out front because they both share a 2x minus 3. Over here I'm left with 2x. Over here I'm left with positive 1. So we'll drop those down. Bring down our 0. Bring down our 2. Now again, in the last unit we would have stopped right here, but now we're not just trying to factor. We need to actually solve for x and get answers that look like x equals some number. So I'm going to use my zero product property and set the first part, the second part, and the third part here all equal to 0, because any of these could be 0 to make the whole equation equal to 0. Now let's go ahead and solve these equations. Looking at the first one, 2 equals 0, that doesn't make any sense. 2 does not equal 0, so we can just reject that part of our work. In our second part here, 2x minus 3 equals 0. We're going to use inverse operations to solve. First, we're going to move the 3. So we'll be left with 2x equals 3. Then we'll divide by 2. And 3 divided by 2, that's a decimal, so I could write 3 over 2. Or if I want, I could write 1.5 if we're feeling like using our decimals. Coming over to our third piece here, we have 2x plus 1 equals 0. Again, using our inverse operations, we'll start by subtracting 1, and then we'll divide both sides by 2. And again, negative 1 divided by 2, we could leave that as negative 1 divided by 2, or if we're feeling like putting our decimals, we could have negative 0.5. So you'll notice that there are two answers to this problem. We could have 3 halves, or negative 1 over 2. Those are both values of x that make this equation true. Okay, so at this point in the lesson, we've come to our checkpoint question. Here's our checkpoint question. It says to solve the equation for all values of x by factoring. So in this lesson, we're going to ask that you actually take a picture of your checkpoint question because we want to see what your work looked like before you went on to your independent practice. So please pause the video, do your best to answer this question on a piece of paper, then come back to the video to check your work. Okay, so if you're still listening to this video, that means that you've already tried this checkpoint question by yourself. Let's go ahead and go over the answers. The first step should have been to move all of these terms to one side. I think it's easier to move everything to the left. You guys usually think that as well. So you should have been left with 3x squared. We can combine 6x plus 4x to give us 10x, and we can combine 1 plus 6 to give us 7. So you should have 3x squared plus 10x plus 7. This equation is in standard form, so it's ready to be factored. We know that in our first method of factoring, we should always look for a GCF. Our three terms here are 3x squared, 10x, and 7. If I think about all the factors of those terms, they have nothing in common other than a 1, so we actually can't take out a GCF here. Instead, we'll go to step number 2, which says to multiply A times C. So 3 times 7 will give us 21. And again, we're trying to come up with the factors of 21 that add to 10. Now, luckily, the only factors of 21 are 1 and 21, and 3 and 7, and it should have been pretty obvious that we're going to use 3 and 7, because 3 times 7 is 21, and 3 plus 7 is 10. Now we go and we take that middle term and we split it into those two numbers. I'm going to put 3x and then 7x. If you put the 7x first, your work is going to look different than mine, but you should still get the same final answer. Let's go ahead and bring everything else down. Now we're up to the last step of this method of factoring, which is to factor by grouping. So I'm going to group the first two terms together. Their GCF should have been a 3x. Taking out a 3x, you should be left with x plus 1. In your second two terms, your GCF should have been positive 7, and you should have also be left with x plus 1, which again, if those did not match each other, your x plus 1 and your x plus 1, you would know that you made a mistake. Factoring the x plus 1 out front because they both share x plus 1, then I'll drop down the 3x and the positive 7. Now again, we have to actually solve for all values of x. So we're going to use our zero product property. We're going to set the x plus 1 equal to 0, and we're going to set the 3x plus 7 also equal to 0. Using our inverse operations, in our first equation, we're going to subtract 1 on both sides, so we get x equals -1. Our second equation is going to take us 2 steps to solve. We'll start by moving the 7. And then we'll go ahead and divide both sides by 3. Now 7 divided by 3, if you do that in your calculator, will give you a pretty messy repeating decimal. So let's just go ahead and leave that as a fraction. So your two answers for the checkpoint should have been -1 and -7/3. So at this point, I want you to kind of reflect on how my work compared to the work that you did in your checkpoint question in order to decide what to do for independent practice. Again, you should be looking in your packet that says Solving Quadratic Equations Part 2. If you had no idea how to solve this equation, you barely could complete any of those steps that I just did, I'd like you to start on the red problems. If you tried to solve the problem but you got stuck kind of halfway through the way, I'd like you to start with the yellow problem, starting with number 5. And if you had all of those steps and you feel like you're really mastering this, I want you to start with the green problems on page 6. So again, you'll notice that for independent practice, in order to get your full credit, if you're going to choose to start with red, you need to do the red and the yellow problems. If you're going to start with yellow, we want you to do yellow and green. And if you're going to start with green, I would like you to do green and the extension. No matter what group you're in, I want you to notice that at this point, you now know how to do 2 more problems in your Regents packet. You should be able to do number 1 and number 20. So if you haven't started that Regents packet yet, I would try to do those problems. So at this point, you should be stopping the video. Please go take about 10 to 15 minutes to work on your practice. Again, please do not rush through this. We need to get our practice so we can get a full understanding of what we understand and what we still need more help with. Then come back to this video to check your answers. Okay, so if you're still watching this video, that means that you have completed the independent practice by yourself. Let's go ahead and check our answers. Here is numbers 1 through 4 on page 5. You'll notice that I usually leave my answers as a fraction, but if you had the decimal equivalent, that would be fine. Okay, moving on to the bottom of page 5, here's 5 through 8. Again, if this is a problem you did, go ahead and pause the video so you can take a look at my work. Okay, let's continue on to page 6. Here is numbers 9 through 12 on page 6. And last but not least, here's the bottom of page 6, numbers 13 and 14. So again, to get your classwork credit for this lesson, we need you on Google Classroom to submit a picture of your checkpoint question and then a picture of your independent practice so we can see what problems you tried based on your checkpoint question. Please make sure that you submit that through Google Classroom to get your credit. Last but not least, on exit ticket 8.2, which you started in the last lesson, please go ahead and try number 2. Again, you don't have to submit this work to us yet. You're not going to do that until you've answered the entire exit ticket, but I would go ahead and try number 2 since that has to deal with this particular lesson.